Hello, today I am discussing about maxima minima in differential calculus. So what is the condition that a graph takes maximum at any point? Conditions required to be a curve at any point be maxima or be minima. So let's take a Cartesian plan first. This is x-axis, this is y-axis, this is the origin O. I am taking a curve in this way. So here, if this is y is equal to fx, a curve, here we can look that this at this point x is equal to alpha, the y takes maximum values. Here y is equal to f alpha. So at this point, the curve has maximum value or takes maximum. So we used to know what is the condition required or how we can calculate the condition that we can find out without drawing a graph that a graph will be a maximum takes maximum value. So we take the two neighborhood points, like here we are taking a point x is equal to alpha minus h, and here we are taking another point x is equal to alpha plus h. There are 3 points A, B, C. So we have to look at the slope at the point B. If we draw the slope at the point B, here y is equal to f alpha minus h, and at the point B, at point A, y is equal to f alpha, and at the point C, the slope the value of y actually alpha minus h, here is f is equal to alpha, and at the point C the value of y is f alpha plus h. So the slope at the point B, if we take theta, and the slope at the point A, we can look this is we are taking theta. This is at the point C, we are taking the slope is alpha. So the slope at the point A is 0, since the tangent at the point A is parallel to x-axis. So here the slope is 0. So how we can now make this? So the slope equation, if we remember, is dy by dx which is a tendency dy dx is equal to tan theta. Here theta is equal to 0, tan 0 actually. So this will be 0. So this is a required condition that the derivative, first derivative at that point where the slope take maxima or minima must be equal to 0. If this is at minimum point, then also the tangent slope must be equal to 0 since this is parallel to x-axis. But how we can understand that at that point or at any point it takes maximum value or minimum value? So we have to go forward for this. If we take at the maximum point, the slopes are decreasing slowly. If we take another point D, at point D, the slope if we draw of the tangent is less than, is greater than the slope at the point B, B, sorry. So at the point D, at point D, the slope is greater than, at point D, the slope is greater than at point B. So here I'm taking, this is theta 1, at the point the slope is theta 1. So theta 1 is then theta. So you put tan theta 1 greater than tan theta. Now tan theta 1 greater than tan theta, then if alpha minus h so as the curve increasing towards A, the points on the curve increasing towards A, the slope, tangent slope will be decreased slowly, and at alpha minus h, the value of the curve is less than the value of the curve at point A. This is at the point B, and this is point at the point A. So the value is less than, but we used to know the slopes calculation to find out the slope is less than, sorry, so this is actually greater than 0. So if alpha minus h greater than f alpha, first derivative of f alpha minus h greater than first derivative of f alpha, since here the slope is greater than, at the point B the slope is greater than the slope at the point A. So if we rearrange this, so first derivative of f at the point alpha minus h minus first derivative of fx at the point alpha is greater than 0. So if we rearrange this, this will be first derivative of fx at the point alpha minus first derivative of fx at the point alpha minus h less than 0. And if we replace this with alpha plus h, alpha is replaced by alpha plus h, then it will be first derivative of fx at alpha plus h minus first derivative of fx at the point alpha less than 0. If we divide it by h and take a limit, by limit into h tends to 0, then we will get second derivative of fx at the point alpha, which is less than 0. So this condition is required to be maxima for any curve, and for minima we have, if we draw again the curve, here the point is, we are taking P, here we are taking point Q, here we are taking point R. So here this is x is equal to alpha minus h, here the point is alpha, and here the point is alpha plus h. So here the slopes if we take another point to understand this, here we are taking point P, Q, R, S, then the slope will get in this way. So this slope is larger. So as the points on the curve going to the minimum point, the slopes are decreasing again and becomes at last at the point P 0. So we can write down that the slopes are decreasing slowly, and at the point it becomes 0. So at point Q, slope is greater than at the point P slope. So at the point Q, the slope is greater than at the point P. So here if first derivative of f alpha minus each greater than first derivative of x at the point alpha, and again we are drawing here again to understand the condition of slopes. Here the slope on x-axis and here the slope so near the point is going to the minimum point is larger, and the far away the point from the minimum point is less. So the points drawing one, two, 3 points we are taking to understand this. Here the tangent with the x-axis, slope is with x-axis. Here the slope with x-axis. Here the slope with x-axis. So the far away the points being from the minimum points, the slope is increasing, and the near points with the minimum point, the slope is decreasing. So Q point, at the point Q, the slope is less than the far points. This will be less than at the point P. Since I have set for 3 points, so the points, the minimum, at the minimum point, the slope will be maximum. So this will be less than 0, less than. So you can write down this. Less than 0. Here I am drawing it together. This is the minimum points increasing. Here we are drawing a tangent. So the slope is being in this way. Here we are drawing the slope. So the near points of the minimum point is greater than the faraway point. So that's why this is the point P, this is the point Q. So the slope at the point Q is less than at the point P. If we now divide by h and take a limit, and if h tends to 0, then we have second derivative of fx at the point alpha less than 0. So we have to rearrange this first. We have to, before taking this limit, we have to replace alpha minus h by alpha plus h, and it will be alpha plus h, this will be alpha, and it will, the sign changes, it will be now greater than 0. So here it will be greater than 0 if we replace alpha, as earlier I have changed this, alpha by alpha plus h, then it will be first derivative of fx at alpha plus h minus first derivative of fx at alpha by h. This will be greater than 0. So I hope you like these videos and you have understood this.